Sir, by R square.
Yes, yes. The system is in equilibrium means you will take a small element here. The small element will come like this. This will be d theta by 2. This will be t and this will be t. The horizontal components cancel out. Vertical components will be t sine d theta by 2, t sine d theta by 2. Now this will be equal to the electrostatic repulsion between Q0 and the charge on the small element. Right? So 2t sine d theta by 2 will be k dq Q0 by r square. The electrostatic repulsion should be balanced by t sine d theta by 2. 2t d theta by 2 is 1 by 4 pi epsilon naught. dq is lambda r d theta. Lambda r d theta, the charge on this lambda is charge per unit length upon r square q naught. Right? This will go, this will go, this will go. T is equal to charge per unit length 2 pi r into 1 by 4 pi epsilon naught q naught by r. Or you can keep 1 by 4 pi epsilon naught as k, I don't mind. Keep it as k capital Q small q naught by 2 pi r square. K capital Q small q naught by 2 pi r square. Problem for the sake of problem. This is a ring of mass m, radius r. You have positive charge uniformly distributed here, negative charge uniformly distributed here of the same linear density lambda. Linear charge density on both sides is the same. Right? You switch on an electric field at time t equal to 0. You switch on an electric field at time t equal to 0. The ring rolls without slipping. The ring rolls without slipping. Find the value of friction. Find friction on it. Find the value of friction. Problem just for the sake of problem. There will be no concept being tested here. It is only to trouble the students.
Sir? So is the answer E lambda r?
Sir, E lambda THANE also.
Okay, then E lambda by r. We go with the majority. Let me also solve it. Have a look at this. You take small element here. This is theta, this is d theta. Positive charge experiences a force in the direction of the field and negative charge experiences a force opposite to the direction of the field. So technically these both forces will cancel out each other. Net force on the body because of electrostatic field will be 0. Then what is acting on it? Only friction. First equation is F equal to ma. How simple it looks like. The second equation will be the torque equation about this. How do I get the torque equation? Torque due to friction I can conveniently take. Torque due to EQ I will have to integrate because it's a variable. Now at an instant E dq is lambda r d theta. dq is lambda r d theta. Right? Torque due to a couple, force into the perpendicular distance. This 2 times into r sine theta. Say something. This is the force into the perpendicular distance. Why 2 times there is a force even in this direction? Both give me clockwise torque. This I will have to integrate from theta equal to 0 to theta equal to pi by 2. This will be the clockwise torque. This is the force. This is the perpendicular distance. Why 2 times? There are 2 similar forces. This will be equal to I into alpha. What will I be? M r square.
Minus FR will
Sorry, minus F into R will be I into alpha. I forgot the torque due to friction. Minus F into R is I into alpha. I will be mr square as it is a ring. Third equation is A is equal to R alpha, the condition of rolling. 3 equations and 3 variables you have got. The integration is not that big a deal, is it? It is integral sine theta d theta. If this is a solid non-conducting sphere, of radius r, total charge is capital Q. There is a bullet of mass m moving with a velocity of u and charge small q entering the sphere with this velocity. Find u minimum. Find u minimum for which the bullet comes out of the sphere from the other side. Obviously solid non-conducting. If not, I cannot keep the charge inside. If it is hollow, how will I keep the charge inside? Hanging in air? It will be solid non-conducting sphere. Only for a solid non-conducting I can keep charge this way. Even if I tell you solid metal, it will be wrong. Even in a metal I cannot keep charge this way. Metal, the charge will come to the outer surface.
Sir?
Yeah.
So we have to neglect the friction inside, na?
Yeah, there is no friction, only charge.
Sir,
Yeah.
what is the mass of this sphere?
Mass of the sphere is not given and you don't need it. That is fixed, rather fixed. Oh, you are conserving linear momentum, is it?
Conservation.
Don't. This is fixed.
Yeah.
Fixed. You people understood why that boy asked that out? If it were not fixed, you will have to conserve linear momentum. Then you need the mass of the sphere. The sphere is fixed. We are dealing only with electrostatics. Keep mechanics aside for some time.
Sir?
Yeah.
So is the answer under root of q upon 2 pi epsilon naught m?
I think is right. Once again, I don't remember the answer. Give me 2 minutes, I'll solve it.
energy conservation here.
At which 2 points?
Just when just before it collides.
Now this is the mistake all of you will commit, hence this question has been given in your booklet. All of you will conserve energy here and here. No, you should conserve energy here and here. If it crosses this point, how will the field lines for this sphere look like? All of this is positive charge, right? They will be radially outwards because the charge is uniformly distributed. From the center, the field lines will be radially outwards. Now if a bullet is entering here with a velocity of u, once it crosses this point, you don't need to give energy for it to move. The electrostatic field itself will push it. So you'll have to conserve energy here, half mu square plus k capital Q small q by r. Right, that's the electrostatic potential energy. It should be reaching here, it should reach the center. What will be the expression for potential inside a solid sphere?
That point it is zero. No.
Center of the solid sphere, 0. Here, K capital Q by 2R cube, 3R square minus 0 square. Small r is 0 at the center. This is the potential. that into small q. Right? So that is the potential of a solid sphere at the center. Hence you should remember this expression. You cannot derive it time and again. You can simplify that, you will get the answer. Find out u. That will be u minimum for it to cross the other side. Are you getting this point? No. These are problems in your booklet where almost every batch will have this as a doubt. They commit this mistake of conserving energy here and here. If you people recollect, even in gravitation we have one similar problem. Firing from here, don't conserve energy between this and this. You will have to conserve energy between this and this point. Naturally it will go into this. Are you able to recollect?
Yes, sir.
Actually, I was solving these problems to buy some time for the latecomers who have come today. Today's class is very important. I cannot start with some of you not yet reaching. Next time 7:30 class, please come at 7:30. Right? When I want to introduce a concept at 7:30, I introduce that for the first half an hour, 1 hour. The remaining concept you people will not understand. Latecomers, all of you, please come at 7:30 from next time. This concept is very important. Whole of electrostatics will be banking on it. Ironically, we start with a small mathematical calculation here. Do you people remember a sector formula L, theta and R? The sector formula will be theta is equal to L by R. We go one step ahead here. What if it is a circle? What if it is a circle? Right? What will be the angle subtended here? If the total length is 2 pi r divided by r, I get 2 pi. Few of you may feel, how did you are doing the reverse. You got this length as 2 pi r from this formula. I didn't. Have a look at this derivation. You will consider a small elemental length. This is theta, this is d theta. What will this length be? R d theta. Sector formula, I used this. I add up all such type of lengths. R d theta, I will add up from 0 to 2 pi. Right? You will get 2 pi r. This 2 pi I got it from here. That is 2 pi for sure we are aware of. Right? So this length 2 pi r, when I substituted, I will get. I have the bad habit of using two different symbols. This is small r, this is capital R. Change it to small r. Use the same r all through. Don't keep changing symbols. Right? One point ahead. Observe this carefully and please pay attention. Andheri, you can do the explanation later. Listen to me. Second bench. Listen. Now here the most important thing is, when you take a closed circle at the center, you are telling me the angle subtended is 2 pi. What if the point is not at the center? What if the point is not at the center? Even then the angle subtended will be 2 pi. How do you justify that? Keeping this as the center, draw a circle. Keeping this as the center, draw a circle. Now join these two. This line and this line will subtend the same angle here. These lines and this line will subtend the same angle here. So for this circle, if the angle is 2 pi, even for this circle the angle subtended here is 2 pi. It is more like telling you, whether it is this line or this line, the angle subtended here is the same. So whether it is this line or this line, the angle subtended here will be the same. Whether it is this line or this line, the angle subtended here will be the same. We add something more important to this. What is it? Now you have been taking only a circle. What if it is not a circle also? The angle subtended inside will be 2 pi for any closed loop. Why? Keeping this as a center, draw a circle. Now this and this will subtend the same angle. This and this will subtend the same angle. Keep joining all of that. Net total angle subtended is 2 pi. So we have concluded on a very important fact. For any closed loop, any point inside, the angle subtended will be pi. For any closed loop, for any point, at any point inside the angle subtended is 2 pi. Technically I don't need this, I want for solid angle, but we will extrapolate from here. Take this down. This is linear angle. Now, how do you define a solid angle? See, this will be a solid angle inside. This will be a solid angle inside. The difference between solid angle and linear angle is this will be a linear angle. If I fold this paper this way, this is a linear angle. Angle subtended inside, that will be a solid angle. Are you able to visualize that? I cannot draw a solid angle on a board. Right? The angle subtended inside will be a solid angle. Fine? Keeping this in view, I will show solid angle by a circle here. This will be area delta S. This will be R. Solid angle is represented by omega. Delta S by R square. Dimensionally this should not have a dimension. Theta doesn't have a dimension. Here is the situation here. Area by R square. If it is this area or this area, both of them will subtend the same solid angle here. As the area increases, the radius also increases. Numerator and denominator will change by the same proportions. Solid angle will remain the same. Solid angle is delta S1 by R1 square, delta S2 by R2 square. Sounds good? If you people observe carefully, area I am showing as a vector quantity right now. Don't you think you are committing a mistake? I am not. From today onwards, for us area will be a vector quantity. Is it to your convenience that we make it a vector whenever you want? You remove it from the vector notation whenever you want? Yes, it is for our convenience that we make it a vector. Till now for you area of a rectangle is only length into breadth. Hereafter it can be this area or this area. Which side also is important, right? So this side perpendicular to the area outwards. This side perpendicular to the area outwards. If I put I cap, it is this area. If I put minus I cap, I am referring to this surface of the area. Are you clear? Hereafter area will be a vector quantity. Perpendicular. How will you show me the direction? Perpendicular to the surface outwards. Outwards. Perpendicular to this surface outwards. Perpendicular to this surface outwards. Right? Now the $1 million question is, what if I take a sphere, what will be the angle subtended inside? Sphere, solid angle is delta S by R square, 4 pi R square by R square. This will be 4 pi. Now you actually understand where from 1 by 4 pi epsilon naught has come. 4 pi has come from here. Right? You will see the logic. Ironically, Coulomb's law was first done experimentally. Gauss law came much later, but Gauss law is more fundamental than Coulomb's law. Now, for a sphere at the center, the angle subtended is 4 pi. What if I consider a sphere and I ask you the angle subtended not at the center but somewhere here? Even then it is 4 pi. The logic you are extrapolating from the linear angle concept. Right? Second, what if the surface is not a sphere, yet the angle subtended anywhere inside is 4 pi. This is something we should know to go ahead with Gauss law. Is the logic clear? Second, surface area of a sphere we didn't derive from this. Don't tell me you derived from this surface area of a sphere taking this as 4 pi. Now you are doing the back calculation. Have a look at it. Surface area of a sphere you calculated by considering a ring. This is theta, this is d theta. Thickness of the ring is r d theta. Surface area of the ring is 2 pi r sin theta r d theta. You integrate this from 0 to pi. The ring that you consider is from here till here. 0 to pi, 2 pi r square. Integral sin theta minus cos pi minus cos 0. I substituted the limits. You get 4 pi r square. You did not use the concept of 4 pi anywhere. Now 4 pi r square by r square, you will get the solid angle subtended inside as 4 pi. Right? This mathematical tool was used to prove a very fundamental property in electrostatics. Take it down till here, we will discuss that.
Sir,
Yeah?
so why is the thickness of the elemental ring r d theta sin theta?
Why?
So r d theta का component है. So the thickness of the ring, why is it r d theta? Why not r d theta sin theta? मतलब it's component.
You will not require that here because d theta is limit delta theta tending to 0. When I make the strip this way, your point is why don't I take this thickness, right? Now this is r d theta.
Yes.
You want this particular thickness. That will be very insignificant because you have taken d theta to be very, very small. Limit delta theta tending to 0.
Okay, thank you.
Why do we write delta S for area? Sir, area should be written as S, no sir. What is change in area, sir? Why do we write delta S, sir?
You don't write
Why
delta
not
S, you wrote
delta?
ds. ds is the area of the small element. ds is the area of the small element.
Sir, but on the left hand side, sir, when you drew the diagram, you showed the area vector as delta S.
Delta in my representation is small area. Very small area is ds. If not, write it as s. S is more appropriate, we don't mind. Right?
Okay.
Now listen. We define a quantity called flux. This electrostatic flux will be E dot A dot product of two vectors, field and area. When did area become a vector? Today area became a vector. E dot A. This will be Newton per Coulomb meter square. A new physical quantity. How do you want me to visualize flux? Number of electrostatic lines of force. Number of electrostatic lines of force. Right? Greater the number perpendicular to the surface, greater will be the flux. But electrostatic lines are imaginary lines. Yes, they are imaginary lines. So it is only for your visualization that we are telling you number of electrostatic field lines perpendicular to that surface. Andheri, second bench. Till the lecture is over, you people will not explain to each other. Listen to the complete explanation. Right? Or else shift from there to another bench if the temptation is too huge for giving the explanation. Right? Now listen. When we are defining the flux E dot A, E is the electrostatic field, A is the area. Dot product of two vectors will be a scalar. Dot product of two vectors will be a scalar. Clear? If I take a particular area like this, and this is the area vector, and this is the field, the flux will be E A cos 0. If I take the other side of the plate, right, and I take this as the area, the field in this direction, flux will be minus EA. Why? EA cos 180. Now you understand the importance of making an area a vector. each side of the area will have a different flux. Clear? Second, now Gauss exploited this particular concept. He said, if I have a particular area here, delta S, right? Why am I taking delta S? It is not change in area. It is an area of a small element. Area of a small element. This is R. What will be the flux through this particular surface? D phi will be E dot ds. This is ds. Field will be directly proportional to 1 by r square. Area will be directly proportional to solid angle into r square. Field will be directly proportional to 1 by r square. Area will be directly proportional to solid angle into r square. Are you trying to tell me that this will be a constant if solid angle is the same? Obviously yes. In the sense, tomorrow if I take this particular area, call this ds dash, will the flux be the same? Yes, the flux will be the same. The flux through both these will be the same. Are you getting this point? As I move out, the area is increasing, the field is decreasing at the same rate. So flux through any of these surfaces, till when the solid angle subtended is the same, the flux through any of these surfaces will be the same. I repeat, till when these surfaces subtend the same solid angle on the chart, the flux through any of these surfaces will be the same. Agreed? Now Gauss said a closed surface will always subtend an angle of 4 pi. So flux through any of the closed surfaces should be the same. He calculated this flux and he told us this is Gauss law. I repeat the last logic. Any of these two surfaces subtend the same solid angle here, hence the flux through both the surfaces are the same. So till when the solid angle subtended is the same, the flux will be the same. Gauss said for a closed surface, solid angle subtended is always 4 pi. So flux through any closed surface should be the same. Is the logic clear? This is the origin of Gauss law. Take it down till here, we will define Gauss law. Before I go into Gauss law, one more parameter here. Now here you moved the area towards this so that the area increased and the field decreased. Suppose I don't do that and I do this. I tilt this particular area here. Now area increased but the field did not change. For the first one it was ds1 this way. For the second one it is ds2 this way. Field remains the same for both the areas. But area of one increased. But both subtend the same solid angle. How do you claim that the flux through both of them are the same? Dot product cos theta will take care of this. D phi is equal to E dot ds1 or E dot ds2. Now this will be E ds2 cos theta. Right? This will be E ds1. These both will be the same as ds2 cos theta is ds1. Are you clear with that? So hence the cos theta will take care of the fact when both the areas subtend the same solid angle at a particular point chart, the flux through both of them will be the same. Now suppose you take consider this. We are trying to establish Gauss law. What did he say? For a closed surface, the solid angle subtended anywhere inside will be the same. Right? So now he calculated how much is that flux. This will be ds. This will be the field. This will be the solid angle subtended at this point by this surface. Right? The angle between the area vector and the field is theta. The angle between the area vector and the field is theta. Now you want to calculate the flux through this particular surface, d phi. You want to calculate the flux through this particular surface, d phi. D phi will be E dot ds. This will be E 1 by 4 pi epsilon naught q by r square. ds, area vector, ds, solid angle into, wait, let's directly keep that as ds temporarily, ds cos theta, ds cos theta because of the dot product. Integral d phi will be the total flux through whole of the surface. This will be q by 4 pi epsilon naught r square integral ds cos theta. Closed integral is the symbol to be used. Why are you emphasizing for closed integral? Because now ds cos theta by r square, have a look at it. E ds2, you said E ds2 cos theta divided by r square will be this particular solid angle. ds cos theta will be this particular area, ds cos theta. Till now in all the explanations that I used, if I am getting this as a solid angle, the area should be perpendicular to r. Area, the small area that you are taking is perpendicular to r. If it is not perpendicular, you resolved it. So this will give me the solid angles obtended here. D phi will be q by 4 pi epsilon naught closed integral d omega. D omega is the solid angles obtended by this area at the chart. Closed integral d omega will be 4 pi q by 4 pi epsilon naught into 4 pi q by epsilon naught. So Gauss calculated the total flux through this particular surface due to a charge enclosed inside to be q by epsilon naught. This precisely becomes Gauss law. Gauss law is closed integral E dot ds. You understand the significance of this closed integral. It should be a closed surface area. Only then the solid angles obtended confidently will be 4 pi. So closed integral E dot ds will be q net by epsilon naught. Q net by epsilon naught. Net total charge enclosed inside. You may have more than one charge. We don't mind. Take the net charge because any point inside the closed surface, angles obtended will be 4 pi. Hence, closed integral E dot ds will be q net by epsilon naught. Take it down till here. There are quite a few intricacies in understanding this. Will explain that.
Sir, will there be any effect if another charge is outside?
Will be dealt with 5 minutes.
Sir,
Huh?
so here the R that you have taken, sir, it's different for the surface on the closed part that you've taken and its component. So the
R will change, I don't mind. Proportionally ds cos theta also will change. Proportionally the value of the solid angle may change, I don't mind. If I am taking here, I will take this area. This solid angle need not be the same as this solid angle. Who is telling you these two solid angles should be the same? Need not. But if I close the complete surface, some of these solid angles will be 4 pi.
Sir,
Hence I converted this into a solid angle subtended. Sum of all the solid angles for a closed surface will be 4 pi. I have made the equation independent of r. If r changes, theta will change. I can even take ds. Here ds is much smaller when compared to this area.
sir, I was asking that when you took the component of a particular area, then R changed.
Let it change. What is the problem for you? I damn don't care about that r. If this changes, area changes, r changes, component changes, I don't mind. but this will subtend an angle of d omega. Sum of all the d omegas will be 4 pi. Is that clear?
Yes.
Now
Sir,
listen
what
to
is
the
the
interview.
physical
Switch off the mics.
significance
All of you
of
switch off the mics. Switch off the mics. Now listen to the most important thing here. The interpretation of Gauss law is E dot ds will be equal to Q net by epsilon naught. Something very dicey will be covered here. Listen to this. You will start assuming a Gaussian surface. Gaussian surface. Who will give you? Will the paper setters give you the Gaussian surface? No, it will be your responsibility to assume this Gaussian surface. Closed surface. Right? How to assume that will be taught in 5-10 minutes. If I have Q1 here, Q2 here and Q3 here, closed integral E dot ds will be the flux through this particular surface. What is integral E dot ds? It is a flux. Right? That will be equal to Q1 plus Q2 by epsilon naught. Q1 plus Q2 is the net total charge inside the Gaussian surface. Q1 plus Q2 is the net total charge inside the Gaussian surface. Why did you not take Q3 inside this? We will not. This will be the net enclosed inside the Gaussian surface. Any charge outside will contribute to zero flux. Are you trying to tell me flux through this surface due to Q3? If I have got Q here in the closed surface, the flux will be zero. Net total flux entering will be equal to the net total flux going out. Mathematically, for you to understand, here E and ds will be parallel, here E and ds will be anti-parallel. So one whole section will give me positive flux, one whole section will give me negative flux. Flux through this surface will be zero. First point, is that clear? Always inside I will take only the net total charge inside the Gaussian surface. That will be taken here. Charge outside the Gaussian surface will not be taken here. What will be more troubling comes now. Please pay attention. But field is due to all charges within the vicinity. Are you suggesting that the field is due to Q1, Q2 and Q3? Yes. Now this is a troubled zone. You will understand that in the next 5 to 10 minutes. Have patience. You are telling me integral E dot ds is Q net by epsilon naught. Here I will always take only the charges inside the Gaussian surface. Because the charge outside will give me zero flux. But charge outside need not give me zero field. Because of Q3, will anybody tell me the field on the Gaussian surface is zero? It's not. Flux through the Gaussian surface will be zero. So field is due to all the charges within the vicinity. How the hell does that work out? I'll explain. Take it down till here. Now listen. Can I rub this part? First of all, we will try to justify what we have told. You are telling me closed integral E dot ds is equal to Q net by epsilon naught. Something that you people already know. I will prove from this so that you will understand how to use this. First point, I have a point charge Q at a distance of r. I am interested to know the field. I have a point charge Q at a distance of r. I want the field. Now what do? I'll assume a Gaussian surface like this, spherical Gaussian surface such that Q is at the center. I'll assume a spherical Gaussian surface, spherical Gaussian surface. How did you know that you have to assume such a surface? You will also know that in 5 minutes from now. I took a small area, that is field and ds. Closed integral E dot ds will be q by epsilon naught. This is what your Gauss law told you. E and ds are parallel all throughout this surface. So you will write E ds cos 0 is q by epsilon naught. Closed integral ds for a spherical surface is 4 pi r square. So field will be 1 by 4 pi epsilon naught q by r square. Something that we know. Now your students all of a sudden wake up and they start screaming, sir, you proved Gauss law from here, you came till here, now you did the back calculation and you are showing me you took a surface, you took 1 by 4 pi epsilon naught q by r square. I am not trying to prove Coulomb's law for you from Gauss law, no. I am trying to explain how you have assumed a Gaussian surface. This is quite obvious. From here you came till here in the derivation. You do the back calculation, obviously you will get the answer. We are not cheating. Right? We are not even proving Coulomb's law from Gauss law. We are trying to tell you how we assumed this Gaussian surface. What were your assumptions? First assumption, I assumed a Gaussian surface whose surface area is known to me. If I assume an arbitrary Gaussian surface like this, is Gauss law valid? Yes. Is Gauss law valid? Yes. But can I proceed? No. Right? First point, I will have to assume a Gaussian surface whose area is known to me, because surface integrals are not yet taught to you. This is a line integral, this is a surface integral, this is a volume integral. These both will be taught to you in your engineering first year. Till then, what do you want me to do? Please deal with line integral or assume a surface whose area is known to you. Second, you brought the field out of the surface, right? That means the magnitude of the field was constant all throughout the surface. Always assume a Gaussian surface such that the magnitude of the field can be brought out. Third and the most important, I should know the angle between E and ds. I take a surface like this, angle between E and ds will not be known to me. Right? It keeps varying. So do not assume such a Gaussian surface. For that instance, even if I would have assumed a Gaussian surface like this with q not at the center, even then closed integral E dot ds will be 0. Will be q by epsilon naught. But I cannot proceed further because see, E will be like this, ds will be like this. E will be like this, ds will be like this. E will be like this, ds will be like this. Angle between E and ds is continuously varying. You will not be able to go about with the integral. Hence, assuming the Gaussian surface should be done in such a way such that these three conditions should be fulfilled. Is that clear? All of you?
Yes, sir.
Take this down, I will dictate the conditions. We are not trying to prove Gauss law, Coulomb's law from Gauss law. We are trying to tell you how to assume the Gaussian surface. Write down the first point. Assume a Gaussian surface. Assume a Gaussian surface whose area is known. Second point, let the Gaussian surface be symmetric. Let the Gaussian surface be symmetric. So that the magnitude of the field is constant. So that the magnitude of field is constant all throughout the surface. Third point, angle between field and ds must be known. Angle between field and ds must be known. Akola, will you switch on the mic?
Yes, sir. Yes, sir.
Akola, are you able to hear me?
Yes, sir.
We used to have two sections of Akola, no, yeah?
So we are having holidays. Summer holidays.
How will we cover the remaining part then? Okay, okay. Listen. What did I dictate? Third point. Angle between E and DS must be known. Put a comma. Preferably 0 and 90. Preferably 0 and 90. Now listen. First point we have addressed. What I have dictated to you are not rules, are suggestions. What if I don't follow these rules? You are welcome. Integral E dot ds will yet remain q by epsilon naught. You may not be able to go ahead in the simplification process, but Gauss law is valid. Clear? It is a fundamental law. Now watch out for this. You were telling me Q net will be the net total charge enclosed inside, but field is because of all the charges within the vicinity. Let me try to prove that you are wrong. This is a Gaussian surface, you have Q here, I have taken Q dash here. Now how will your derivation change? Nothing will change. Closed integral E dot ds will be equal to Q by epsilon naught, because you told me not to take Q dash inside. Because you told me Q dash will contribute to zero flux, I did not take. But then the derivation will be the same. I will get the same value. How can you tell me field is because of both? Derivation will not be the same. Field because of this and this. Here maybe this way, ds is this way. But here field because of this and this will be somewhere this way, and field will be this way. Field because of both of them here will be this way, field will be this way. So angle between E and ds is changing. This law is valid. I cannot proceed further beyond simplification because I don't know how the angle is varying all throughout. Under those circumstances, what do you want me to do? Calculate the field because of this, calculate the field because of this, and add them vectorially. Is the point clear? What I am trying to prove is the field is the net field due to all the charges within the vicinity. If I have Q dash, the field here will be this way, field here will be this way, field here will be this way. Here the field is parallel, this way, assume it is in this particular direction. But the angle between the field and ds is changing continuously. Clear with that?
Yes.
Hence, Q net will be the net total charge enclosed inside the surface. Field will be because of all the charges within the vicinity. I will prove this again in another 5 to 10 minutes. Can I rub the left part of the board? Now the question asked by the other student, what did he say? His point was, what if the charge is on the surface? For us there will never be charge inside and outside because it is discrete. The minimum amount of charge that I can play with is 1.6 into 10 raised to minus 19 coulomb. Technically, Gauss law should be written this way. E macro dot ds will be equal to Q net by epsilon naught. Why are you telling me E macro? Gauss law will be macroscopic in viewpoint. Why are you telling me that? Because in the concept of an atomic model, you eliminated the concept of an orbit and you made it orbital. And in orbital, what did you tell me? Probability of finding the electron anywhere in the orbital will be greater than 0. The electron may be here, the electron may be here, the electron may be here. Now how will you apply Gauss law to this? You cannot, because if I take a Gaussian surface like this, I don't know if the charge is inside the Gaussian surface or outside. You will give me probability for inside and outside. Now application of Gauss law will become impossible because you don't know the net charge enclosed inside. Hence, it is E macro dot ds. Now you will never ever tell me that in a Gaussian surface the charge is here, what part of it is inside or what part of it is outside. We are not going to apply it on microscopic viewpoint. It will always be macroscopic viewpoint. So the charge will either be inside the Gaussian surface or outside. If not, it will be shared by both surfaces. We are okay with it. Solid state chemistry, they tell you this corner is shared by 8 cubes. Yes or no? This corner is shared by 8 cubes. Then what ratio of the charge comes inside? Q by 8. Fine. Covalent bonding is recognized by Gauss law. One electron can be shared by 2 particular atoms. But then when we share it, we will distribute it equally.
Sir,
Yeah.
suppose the volume, the complete volume of the space is filled with charge. Then if we wish to apply Gauss law there, each surface we take will have charges on its surface.
Volume means
The complete 3-dimensional space.
okay.
So then if we take any Gaussian surface, we will have to have charges on its surface always.
That will be always outside.
Whatever Gaussian surface is.
That will be outside. If this is a Gaussian surface,
then suppose we take anything, then the surface will also contain charge.
let it.
So how will we deal with that charge? Is it outside?
I will have to assume the thinnest possible surface which is thinner than that of an electron. So either the electron is inside or outside. You cannot have a charge lesser than that of an electron.
But
Right.
When
See,
when
basically
we take
Anuj, we'll discuss this later here.
Yes sir, I'm waiting here. Yeah.
Listen,
Okay.
as far as
Okay.
we are concerned, the charge is either inside the surface or is that clear? Now, make a note of this. You need to make a note that E macro dot ds is equal to Q by epsilon.
Sir,
Yeah,
you are not visible to us clearly.
NERUL.
NERUL system.
NERUL connectivity का problem है. Disconnect करके कर लो.
Sir, if the charge
1 second, NERUL, they disconnect and connect again. Wait.
Sir, if the charge is outside, we need to consider E net, right?
Sir, what about,
Always it is
sir,
E
can we
net. The
assume-
field that you are getting is the field due to all the charges within the vicinity. But Q will be the Q net enclosed inside. Huh?
Sir, can we assume equipotential surface to be Gaussian surface?
Gaussian surface can be anything to my convenience. Right? It is not that it should be an equipotential surface. If you get it, it is well and good. If not, It has got nothing to do with equipotential surfaces.
Sir,
Huh?
sir, why did you call Gauss law as a more fundamental law if you derived it from Coulomb's law?
You will
5 minutes
understand
ago.
that when we come to Maxwell's relations, there are 4 fundamental laws from which whole of electromagnetic theory can be explained. Today we are explaining only one part of it. Electromagnetic theory completely is explained by Gauss law for electrostatics, Gauss law for magnetism, Faraday's law, I misplaced the third law, and Ampere's law. These are the 4 laws which will explain whole of the electromagnetic theory, hence they become fundamental in nature.
Sir, the diagram which you drew at the right hand side. सर जो पहले निकाला था सर जो स्पीयर सर उसके बाहर एक चार्ज था अंदर एक चार्ज था तो सर I didn't understand the direction of field which you wrote. Sir,
Because
like
of these 2 charges, the field may be, because of this the field will be like this, because of this the field will be like this. The resultant field may come this way. Now ds will be like this.
Sir.
I don't know the angle
Yes, sir,
between
got
them.
it, sir. Yes, sir.
Right. Hence,
Sir, thank you, sir.
Sir, in the case of atom, is it that Gauss law is not valid or is it that we are not able to apply it?
Gauss law is universally valid. We don't apply it for microscopic viewpoint. We apply it for macroscopic viewpoint. Because in a microscopic viewpoint, uncertainty principle will come on our way. We don't know if the electron is inside the Gaussian surface or outside the Gaussian surface. Now listen to this. The way we have introduced this concept of assuming Gaussian surface, a student feels that because it should always be symmetric, always I should assume a spherical Gaussian surface. Need not. Best possible example is an infinite long wire. Infinite long wire. Here if I assume a Gaussian surface which is spherical, I am in trouble. The field will be this way, ds will be this way. Here field and ds will be this way. This angle keeps varying. I can tell you what is closed integral E dot ds, but I cannot proceed further. So what kind of a Gaussian surface will you assume for an infinite long wire? You will assume a cylindrical Gaussian surface. Right? Here this will be E, this will be ds, this will be E, this will be ds, this will be E, this will be ds. 3 surfaces, one here, one on the curved surface. What did you tell me? Preferably assume Gaussian surfaces whose surface area is known and the angle between them should be known, preferably 0 or 90. Now when you write closed integral E dot ds is equal to q net by epsilon naught. What is q net? Net total charge enclosed inside. I will write this as E dot ds1, E dot ds2, E dot ds3 will be equal to q net by epsilon. E dot ds1 will become 0. Why? Perpendicular. E dot ds3 will become 0. Why? They are perpendicular. I am left with E ds2 cos 0 is q net by epsilon naught. If I take this length to be L, what is the net total charge enclosed inside the Gaussian surface? Lambda L. If I take length of the Gaussian pill that I have assumed here to be L, net total charge enclosed inside will be lambda L. This will be E 2 pi RL is equal to lambda L by epsilon naught. E is equal to 2k lambda by r. Was this the formula that you derived when you derived the field because of an infinite long wire? 2k lambda by r. So now first point I proved is two important inferences. Please pay attention here. I'll give you time to write. Validity of Gauss law, first point. Second, how did I assume a Gaussian surface?
Then it should be 0.
Right? Third and the most important inference. When you derived this from minus to plus infinity and got the answer. Now by taking the charge only inside the Gaussian surface, you are getting the field because of all the charges within the vicinity. You have proved your point that it will be the charge enclosed inside, but field will be because of the net total field. Now my point is, where in the derivation did I conceal the information that the field I am calculating is because of the infinite large line? Somewhere in the derivation I should have done.
E constant.
Not only that, I have taken E constant all throughout the length. If this were a finite wire, E will not be constant. Above all, direction of E will not be parallel to ds2 all throughout the surface. By taking cos 0, I concealed the information that the wire is infinite long. If it were a finite wire, field here and field here need not be the same. To add to that, field and ds need not be parallel all throughout the surface. If you people recollect, for a semi-infinite wire, the field here will make an angle of 45 degree. Here it may be this way, here this way. Slowly as I am coming down, the angle between field and ds will be changing, increasing rather. At this point, the angle is 45 degrees, right? The fact that you have taken E and ds parallel all throughout the surface tells you that the wire is of infinite length. Is the logic clear? All of you? Quick. You may ask, implies I cannot use Gaussian surface to calculate the field for a semi-infinite wire. Yes, I cannot. Because the angle between E and ds is changing continuously. Is Gauss law valid? Yes. I will stop at closed integral E dot ds is equal to q by epsilon naught. I cannot cross that limitation. Now listen. Because we do not have surface integrals in our syllabus. Right? Any question given something related to surface integrals, keep it in mind, you will have to solve it using Gauss law. Can you give an example? There is a square plate here at a distance of a by 2, you have a charge. Square plate ka length of the edge is a. They will ask you to find out the flux through this plate because of this charge. Traditionally, what am I supposed to do? I should consider an elemental strip here. Because of the charge, the field lines will be passing through the strip. I will have to integrate once to get the flux through the strip. Then I will have to integrate from here to here to get the total flux. That is what we mean by double integral, surface integrals. To avoid this, there is one alternative. You will have to take off Gauss law in some or the other way.
Sir, is the answer q naught by 6 epsilon naught?
Can you wait please? Right? Now
Okay.
what we do is, we assume a cube of this form such that charge is at the center. This distance will be a by 2 and this distance is a. The total flux through whole of the cube total flux through whole of the cube is Q by epsilon naught. Because the charge is at the center, mind my language, because the charge is at the center, flux through each surface will be Q by 6 epsilon naught. What if the charge was not at the center? Then this will be true, but this will not be true. Hence, you will have to think of an indirect means of solving such type of questions. Will there be an indirect means? Yes, because surface integrals are not there in your syllabus. Clear with that? Second example in this category. Take this down, I'll come to that. Yeah, you are right. It is Q by 6 epsilon naught.
Sir?
Yeah.
So could you please explain that surface integral again? What was the procedure?
One second. Give me this. क्या integration कर रहा है यार? X square plus 3x cube कुछ भी. Listen, if I have a charge Q here, I will consider an elemental strip here. Then the field will be integrated from here till here. E dot ds. Right, field will be integrated along this. That flux I will integrate from here till here to get the field all throughout, the flux all throughout this particular phase. Right, when I considered a strip here in the charge, E dot ds will go along this line. E dot ds will go along this line. The angle will keep varying. So I will have to integrate the flux to get through a strip. That I will have to integrate from here till here to get the flux through whole of the surface.
So I have a silly doubt, so one small doubt. So in the case of finite wire, so we can consider a cylinder at the midpoint of height h, and so we can say that h is tending to 0. So then cylinder के the curved surface area पर we can assume that the field is horizontal ना.
But then upper and lower surface of the cylinder.
हाँ, okay. Okay, thank you.
Sir, the flux you calculated is for the upper surface, huh? Or for the whole body?
Lower surface. If it would be upper surface of this
Sir,
plate, then it will be negative. If I take the plate this way.
Yeah, sir, for the whole body then it will be 0 now.
Will you listen to what is being told? Cool. Whole of the body ka outer surface we have taken. Whole of the body ka inner surface we didn't take. For whole of the body's outer surface, it will be Q by epsilon naught. Why will it be 0? I will not take the outer surface for the lower one and inner surface for the upper plate. अगर इसका outer surface लिया तो इसका भी outer surface, इसका भी outer surface, इसका भी outer surface लूँगा. Then it will be Q by epsilon naught. Why will it be 0? All surfaces will be positive.
Sir, so I am telling that for the upper surface you calculated Q by 6 E naught, now.
We should nomenclate this. O 1, 2, 3. Flux through O 1, 2, 3 will be Q by epsilon. Q by 6 epsilon. Upper किया ही नहीं मैंने, because I asked for this plate. Is that clear?
Sir, so I am telling that for the upper surface the direction of the field and ds is opposite, na?
You mean this surface?
No sir, on the left side of the board.
Right. If this is a
on the upper
plate
surface.
O1, 2, 3, there is a surface ds this way, there is a surface ds this way. I am not dealing with this, I am dealing with the outer surface of this.
Okay, sir.
So, in the case of infinitely long wire, can we assume a cube for a Gaussian surface?
Try that. You should be made to stand upside down for the remaining part of the life. Listen, this field will be radially outwards. If I take a cube, how will I know the angle between E and ES? No, yeah, the field will not be perpendicular to this surface all throughout. Field will be radially outwards for this wire. If you are seeing the top view, the wire will be a dot. Field will be this way. Right? If I am seeing the top view, now I assume a cube. Oh. Yes or no?
Yes, sir, yes.
Now let the class go ahead, switch off the mics for some time. Now listen. The next question they designed on this is, if I have a charge Q at the corner of this particular cube, please pay attention here. Once again, it is 3D, visualization will not be easy. Right? I'll name this 0, 1, 2, 3, 4, 5, 6, 7. That corner is shared by 8 cubes. Is that point clear to all? That corner is shared by 8 cubes. Sorry, state chemistry में किया हुआ है. FCC. Listen. How do I show this corner of this classroom here? So you can camera it. Let's take this help. Have a look at this. This corner will be shared by 8 boxes because there will be 1 in the front, 2 this side, there will be 4 on this floor above. Right? So this corner is shared with 8 cubes. Is everybody clear about it? Sure. If that corner is shared by 8 cubes, total flux through whole of this cube is F total is Q by 8 epsilon naught. I don't have a problem till there. Now they ask you flux through each of the faces. 0, 1, 2, 3. Flux through 0, 1, 5, 4. Flux through 0, 4, 7, 3 will be 0. Why will it be 0? The field lines from Q will go parallel to this face. E dot ds will become 0. Field lines from here will be going parallel to this face. Field lines from here will be going parallel through 0, 4, 7, 3. Hence the flux. If this is the corner, field lines through this top, this surface and that surface will be parallel to the surface. E dot ds will be 0. Clear? The balance will be shared equally with flux through 4, 5, 6, 7. Flux through
1, 2, 5, 6.
1, 5, 6, 2. Flux through 2, 6, 7, 3. 2, 6, 7, 3. This will be equally shared by symmetry. It becomes Q by 24 epsilon naught.
Sir, on the left hand side, sir, you have written flux total, sir, that is through one cube, right?
Cube, through one cube, through this cube only. Through this cube only, the other cubes are not under study.
And sir, those 8 cubes, sir, can you show once again, sir, those 8 cubes? The
This will be, suppose if I take one box, this corner, I can have, bring your book here. Keep your hand underneath the book. Lift it, let the camera be visible. Lift it, further. Yeah, this is one cube. I am studying this corner. Right? So I place one cube here, one cube here. Hold. And another cube here. Right? Now understand. Keep your show the center. The center. That center is shared by 4 cubes. Remove your finger. Right? There will be 4 cubes above this. So that corner is shared by 8 cubes. Clear?
Got it, thank you, sir.
Notes.
So that's 0.
Listen. These field lines from Q, they will be going parallel to the upper face. They will be going parallel to this face. And they will be going parallel to the face behind this particular board. 0, 4, 7, 3. Flux is E dot ds. So flux through 0, 1, 2, 3 will be 0. 0, 1, 5, 4 will also be 0. Field lines will go parallel to the surface. Area vector is perpendicular. That's why we told you how to visualize the flux. Number of field lines intercepting a surface perpendicularly.
Yes.
Sir,
Yeah.
Sir, you right now sometime before you said that we cannot assume a charge to be on the Gaussian surface. It has to be either inside or outside.
Perfect. But sharing is permitted. We recognize covalent bonding. The charge is at the corner. It is shared by 8 cubes. Now here there will be a very valid point. In the process of sharing, how do you know that that corner is equally shared? There is a probability that greater ratio comes in. Microscopic viewpoint we will not touch. We will go with macroscopic viewpoint. So if a corner is shared by 8 cubes, we will take 1/8 of it in each cube. Now listen, the charge is at this corner. If the charge is at this corner, flux through this surface will be 0. Flux through this surface will be 0. Flux through this surface inside will be 0. All 3 surfaces, right? 1, 2 and 3. Agreed? Now if I have a charge at this corner, now understand, flux through this surface and the lower bottom will be equally distributed. Charge is at this corner. This surface will be 0, this surface will be 0, this surface will be 0. But this and the lower bottom will be symmetric for this corner.
Yes, sir.
Right? So, total flux inside this particular box will be Q by 8 epsilon naught, Q by 8 epsilon naught, Q by 8 epsilon naught will be equally shared by these 3 surfaces. If the charge is here between this and this, it will be Q by 24 epsilon naught each.
sir, but
Thank you, sir.
Sir, the front surface is a bit farther away from the charge.
अरे नहीं, this is not a cube, this is cuboid. यहाँ cube लिया हुआ है.
अरे
I don't have a cube here, so I took the help of this. नीचे कैसा होगा यार? Right में से Now listen. I need to get 1 second. Switch off the mic. The relation between solid angle and the linear angle. Now listen. The solid angle subtended by this area is this. The linear angle will be theta. I want the relationship between the two. I will remove this part, it is of no interest for me. The solid angle is subtended here and the linear angle, I need the relation. The radius is R. How do I get the solid angle? S divided by R square. How do I get the S? Consider an element here. This angle is alpha, this angle is d alpha. The thickness of this ring is R d alpha. Radius of the ring will be R sin alpha. Why are you interested in it? I will calculate the area of this ring. ds will be 2 pi r sin alpha r d alpha. 2 pi r sin alpha will give me the length into breadth is r d alpha. If I integrate this 2 pi r square integral sin alpha d alpha, least value of alpha is 0. When I consider the ring on the topmost point, least value of alpha is 0. Maximum value of alpha is theta. The ring that I consider is from here to this ring. Theta 0 to theta. S is 2 pi r square integral sin alpha d alpha minus cos alpha 0 to theta. S by 2 pi, S by r square will be my solid angle. Area divided by r square will be equal to 2 pi into 1 minus cos theta. Can I bank on this relation always? Yes. Solid angle is 2 pi into 1 minus cos theta. Can I cross verify? For a hemisphere, theta will be pi by 2. For a hemisphere, theta will be pi by 2. Cos pi by 2.
0.
Solid angle subtended 2 pi. For a complete sphere, theta will be pi. See the value of theta. Cos pi minus 1. 1 minus of minus 1. 2. 2 into 2. 4 pi.
So,
Yeah.
so if we take the area of the circular plate, the one with radius r sin theta, so उससे we can obtain the solid angle, ना?
How? You have taken the
So
area of
in that
this
case,
ring.
would it be no?
Solid angle is omega. This one.
So we can use a cone kept horizontal.
ये सब करूँगा भैया. 2 स्टेप में जब ये हो रहा है वो सब क्यों करने का? This area divided by r square is this solid angle. How will I get the total dome's area? I took the area of the ring and I integrated to get the total dome.
No, sir. I meant that why don't we take the area of the circular plate, the one with radius r sin theta, and then the perpendicular distance r cos theta. मतलब s will be pi r sin theta whose pi r square sin square theta upon r square cos square theta. That way.
When you are calculating the solid angle subtended by that area, by that small elemental area, I want the solid angle because of whole of this. Maybe I didn't get what he is saying here. Doesn't matter here, do it this way. Which center is that? CHEMBUR. Quiet, quiet. There's a lot of noise in your room. CHEMBUR. Cool, cool.
So I meant like in a cone we take a circular plate, and that way we calculate the area and then the perpendicular distance. So in this same way, why don't we do that in this?
Nobody understood.
So there's a so the circular.
Wait.
ring-
You understood this?
Yes, sir.
That's it. Right. There are 2 more things I should complete before 10. Wait. Can I have the board? Huh?
Does the linear angle corresponding to that solid angle?
Linear angle. For this solid angle, linear angle is theta. 2 pi into 1 minus cos theta. is a linear angle corresponding to the solid angle. Linear angle, full angle, half angle क्यों यार? आपको जो angle diagram में दिया गया है देख लो एक बार. See, the linear angle is this. For this relation we have found out. We have found out the relation between this and the solid angle subtended by this area here. Relation between theta and this solid angle. Now don't ask me why did you select that angle, because we need it. You will understand that later. Right now, do you understand the relation between theta and 2 pi? That's it. Don't take another angle and tell me find the relation between that.
Thank you, sir.
Okay, listen. On this concept, one problem from Iridov, one problem from Krotov. This is a disk given by Iridov and he is asking you if this distance is d, this distance is also d, what is the flux through this particular surface? If I were to solve this traditionally, because of this charge q, I will assume a particular ring. Listen, you have a charge q here and a disk. Traditionally, when you solve this q, I will take the field through a ring and area vector this way. That I will have to integrate all throughout the ring. What I get is the flux through an elemental ring. That I will have to again integrate from here till here and get the total flux through the disk. Agreed? But we are not going to do this surface integrals. We will have to think of an alternative called Gauss law. How do you go about with that? When you dealt with this derivation right now, the relation between solid angle and linear angle, if I keep a charge q here, the solid angle subtended by this surface or the solid angle subtended by this surface here will be the same. Solid angle subtended by this dome shaped structure or solid angle subtended by this circular plate here, both of them will be the same. Yes or no? Yes. Now, flux through both of them would have been the same if I have a charge q here. Now I use this. I have a charge q here. Keeping this as the center, keeping this as the radius, can I draw a spherical surface like this? The flux through this circular disc, all this dome shaped structure because of this q will be the same. Yes or no? Now, how will I get the flux if I get this solid angle? For 4 pi solid angle, the flux will be q by epsilon naught. Who told you that? Gauss. Right? For this solid angle, it will be 4 pi epsilon naught into that solid angle. For 4 pi solid angle, it will be q by epsilon naught. For this solid angle, what will be the flux? Q by 4 pi epsilon naught into the solid angle. Do you know the value of the solid angle? Q by 4 pi epsilon naught into 2 pi into 1 minus cos theta. Cos theta value is known to you. A is given, D is given. Under root A square plus D square. This will be Q by 2 pi epsilon naught. 1 minus cos theta is D by under root pi square. Q by 2 epsilon naught into this value A square plus D square in the denominator with a square. Listen, problem is not over. You have calculated the flux through this disk because of one charge. Answer will be Q by epsilon naught 1 minus D by under root A square plus D square. Why? You are multiplying this with even this. Look at the smartness here. If I have a charge Q and charge Q here, what will be the flux through this disk? 0. Because the field lines will go this way. This will go this way. This will go this way. There will be no flux through this particular surface. right? So now if I add two charges on both sides, it will not contribute to any change. So now I add plus q here and plus q here. This will become 0. Because I added plus q here, it will be 2 times this answer. Yes or no?
Yes, sir.
All of you? Quick.
So can you explain why we can add plus q?
If I have two plus q charges, what will be the flux through this? This will be the field lines. So flux through this will be 0. Yes or no?
Yes.
Now I added q and q here because I have not changed the problem. Q and q minus q will become 0. Here this became 2q. Awesome idea, right?
Sir,
Huh?
sir, if we have charge Q and Q, sir, we initially know that there are no field of lines then.
Yeah.
Sir, but if we didn't know, then flux is scalar, right? So what we have found out there, that will be multiplied twice for charge Q and Q.
No issue. You want to tell me? No. Why I did that is students have a difficulty in visualizing one thing. If I had only plus q, lines would have been going this way. Because of minus q, they turn into it. So the flux increases. But instead of that, this will be a better logic, no here.
No, sir, I'm asking why would it be 0? Using the derivation, how can we find out?
There will be no lines passing through this. We have drawn the electrostatic field lines for q and q. किया है कि नहीं हमने? Q and Q का draw किया कि नहीं?
Yes, sir. Yes, sir.
Last question of the day. I will leave it as homework for you people. It is a good one. It will be a good brain teaser. Question is from Croto. If people have access to that book, please have a look at the solution behind before you come to the next class. People who don't have access to the book, please try. Croto says this is Q1 and this is minus Q2. There is one line of force going from here till here. Another line of force going from here till here. He says this angle is alpha, this angle is beta. Find the relation between alpha and beta. This is one line of force, this is one line of force. This is Q1, this is minus Q2. Find the relation between alpha and beta. It is related to Gauss law and flux. Gauss law is not over. Today we have only defined Gauss law. Don't jump to conclusions and try problems from it. Please finish HCV, scalar, field and potential and try only this problem as homework. We will need another 2 lectures, only then I can give you homework from Gauss law. Clear? Say thanks. Thank you.